Alright, so now let's continue with the next method. So this one will be the remove edge V. It takes two vertexes, so it removes an edge between two vertices. So we'll say removes an edge between two vertices of the graph. We'll say at param index 1, the first index, and at param index 2, at param index 2, the second index. So we'll say public void remove edge. It takes index 1 and should take a int index 1, because indexes they're stored as a integer, and int index 2. Because we're gonna search for array of index 0, array of index 1, array of index 2, and so on. So when you go for int I equals 0, I is less than array.length I plus plus, then we're going to say array of index 0 points to probably null in this case. If not, we'll just directly change it. Actually, yeah, you don't need to do that. You can just directly change it. You don't even need to loop it. So here we'll say if index is valid, pass an index 1. Then we'll say false is equal to false, or index is valid, or index is valid, index is valid. Passing an index 2 as a parameter is equal to false. So what we're saying is if index is valid, so if index 1 is not valid or index 2 is not valid, then we can return null, throw an exception, or just print a message, something like that. You could have had a index is valid exception, index is valid exception, but I didn't create one. If you want to throw it and stuff, you can put here throws index is valid is invalid exception. You can make an exception, you can throw it, then here you can throw it as well. It's up to you, doesn't really matter. You can return null. If you can make it t, you can actually we probably should have made this t so we can return it, but that's fine, it doesn't really matter. We can return the value, you don't have to. It's good practice to return it. In this interface in the book, they didn't ask for a t, so that's probably why I did it this way. So here we'll say system.out.println index is not valid. Then we'll say not removed. That's a string, then we'll just return. Return just means you're going to break out of the method. It's just a trick to break out of the method, and then here we'll say a dj matrix of index 1, array index 1, so ADJ matrix of array index 1, and then array index 2 on the next index equals to false. Then here we'll do the opposite, so it's a undirected graph. I believe that's what they call it. Then here we'll say matrix, so matrix of a adjacent matrix of index 2, and then index 1 equals to false, or set to false, points to false. All those are fine. Then we'll say edge count decrement by 1 and mod count decrement by 1, sorry. Then here we'll do the expand capacity method. So we'll say creates new arrays to store the contents of the graph with twice the capacity. You could say here returns void if you want, so you could be like at return void. Doesn't matter. Here we'll just suppress warnings. We'll say public void expand capacity. So we'll create an array here. You can just call it larger array, larger vertices, doesn't matter. Larger vertices points to casted T array to new object. We cast a T array to a new object, pass in vertices, and then we pass in the index, so new object of index vertices dot length times 2. So it's going to double the size from 5 to 10 in this case. Depends how many times you called expand capacity. You could go 10 to 20, 20 to 40, etc. So again, there's a lot of, in that case, you can allocate a lot of memory for stuff that you really is empty. So let's say at one point you're going to have an array of 500,000 elements. So if you double that, then you're going to have so much empty wasted space, and if you eventually get to 1 million, then you're going to have 1 million empty spaces. So that can be inefficient versus a linked data structure, which just is a dynamic data structure. It adds space as needed, doesn't really waste space. It's a little more difficult to traverse through though. But I guess, yeah. So you can always probably make a method to delete the extra spaces in the array, but it gets tricky, right? So perhaps instead of doing times 2, you could maybe add like 10 elements or something each time. That might work better. So in here we could say like plus 10. That probably should work. Plus 10. That might be a better solution, but here we'll just multiply by 2, because that works. So after that, we'll just create another bool. So what I did, I believe, is I just said vertices points to, I used the built-in method. I believe you can also use the actually we didn't end up using it, so I didn't need to include that. Import Java .util. What we could have done is we could have called the arrays.copy of method, and we could have just copied a new array to that one. because here we're just saying T larger vertices points to T. So we're going to create a new array, instantiate a new array here, right? Instantiate a new array. We're going to copy the elements into the new array, it looks like. And we have to do that with both the one-dimensional array and the two-dimensional array. So here we'll say larger ADJ matrix. But originally, by the way, what I did, I mean, maybe not this time, but when I went like, because you can do arrays.copyOf, and you can copy the old array to, it takes a length. That would work too, but the thing is when I called that itself, it got mixed up in the memory locations. It wasn't able to do them all. So what you can do is create a new array like this, and be like larger vertices points to. That way it should work. So there's two ways to do this. So you could do something like this, larger vertices. You can try just doing it singly, like without copying it to something else, but you'll see probably it'll get the memory locations mixed up, or you won't see all the memory locations for some reason. But if you do this, it should work. Point an array object reference variable to like this, something like this, T array larger vertices. If we were just to put a semicolon there, then you could point it to arrays.copyOf. That should work as well. That's another method. That's an optional method. This way we just did it by default to copy it. So we'll say larger. That way is probably easier anyways, by the way. This just takes a few lines of code versus this one. We're going to have to loop through it, but we get to practice looping through a 2D array anyways. So here we say Boolean 2D array, so Boolean 2D array larger ADJ matrix points to new Boolean of vertices dot length times 2, and then array index vertices dot length times 2 as well. Whoops, not used to those without looking. Alright, so then we'll do for int. I should put it up here. So for int I is equal to 0. I is less than num vertices. I plus plus. It's going to need a capital V there. So we're going to do a double loop, nested loop through the 2D array here. We say for I is equal to 0, I is less than num vertices. I believe dot length would have maybe worked. But actually we just want to loop through the elements that we have, so this may work better. Okay, so we're doing a little trick here. It's not a standard 2D array loop, we're just looping through to the num vertices. So then here we'll say for int j is equal to 0, j is less than num vertices, j plus plus, because usually here we go num vertices of array index I. But that's okay, this should work. I've already tested this like a while ago. So larger ADJ matrix of array index I and then j points to ADJ matrix of array index I to array index j. Of array index j, yeah. So we're going to say, okay, well, whoops, where's my semicolon? So a larger adjacency matrix of array index I, j, array index I, array index j points to adjacency matrix of array index I, array index j. Then here below that we'll say larger vertices of array index I. Oops. Points to vertices of array index I. And here we'll say vertices points to larger vertices. Then here we'll say ADJ matrix points to larger ADJ matrix. That should be done. If you're confused, you can just use the debugger to go through it. Shouldn't be too hard. So yeah, that's done. So then after that, that should be about it, everything. Size is empty. Let me just double check to make sure we got everything. So this was expand capacity. Before that we had remove edge, takes 2 indexes. Before that we had remove edge. That should be good. So now we'll do the size is empty, and I'll do them under here. What is this asking for, by the way? This is asking for is empty and size. Okay. Just is empty. Didn't we have size on here? We did. Alright. So hopefully you're still with me. We will continue with the is empty and size, just one-liners for those. So we'll do public int size returns a size. Oops, no, return num vertices. I mean, for the doc, returns the size of the graph, so returns num vertices. That's it. Size returns num vertices. That's the count, basically. We could have just called it count, to be honest, but that works. So then here we'll say public boolean is empty, so the standard methods we usually do for our data structure. So we'll say public boolean is empty. We'll say return size is less than or equal to 0, or you can return count is less than or equal to 0. Doesn't matter. I mean, num vertices. Just another way to do it. It works. So it returns the size. Whatever size returns, num vertices is less than or equal to 0. So just a trick way to do it. Usually we just do count. Return count is less than or equal to 0. But that works too, doesn't matter. So then I have the is connected. That uses the traversals, the breadth first traversal and depth first traversal. So here we'll just do, we'll say returns a copy of, we'll do another small method here, so we'll say returns a copy of the vertices array, just a one-liner. Whoops, so we'll say public object array get vertices. And we will say return vertices. Return the vertices array, that's it. Returns an object, what happened here? Public object array get vertices with the param. There we go. So just a getter for the array. Maybe you can set the array if you really want to. create a setter for it. It's just a getter and accessor. So here we'll say returns a copy of the adjacent matrix, AGJ matrix. Maybe I should turn my light on here. ADJ matrix returns a copy of the AGJ matrix 2D array. That's it, 2D. Oh no, just 2D array. That's it. Here we'll say public boolean. Array get ADJ matrix. Return a DJ matrix. Alright, we'll just leave it like that. Alright, so we'll do a toString, and I believe that's it. We're not going to do the iterators. Basically, it just do. Actually, maybe we could do the iterators. And not the whole thing, but I'll show you how to do is connected. They do what I was saying. They basically check if every index is connected, like the 0 to 1, 0 to 2, 0 to 3, 0 to 4, that thing. There's a shortest path. That one's long. I don't know. I don't think we'll do that one. Shortest path. Shortest path. There's like a graph iterator in here. Again, I said I might do a part 3, just because that's, oh god, that's another double of what we just already have. So imagine everything we have, that would be times 2. That's how big it is. It's just massive. So I'll probably come back and maybe make a part 3 later on. So let us do the toString then. toString. We might just finish up on this. So we're just gonna loop through the 2D array. We're just gonna loop through it. So we'll say at override. Is that how you spell it, I believe? And we'll say public string toString. So we're overriding the toString. We'll create a string str points to empty quotes. We'll say system.out.print ln. This is the vertices. We'll say for int I is equal to 0, I is less than vertices dot length I plus plus. Whoops, sorry, just hit the mic by accident. So for int I is equal to 0, I is so for int I is equal to 0, I is less than vertices dot length I plus plus. So we're just going to standard loop through an array basically. We'll system.out. So we did it a little bit different here. So what I did is this. It might work, but it might not always work, so that's the problem. So we'll say system.out.print line I went vertices of array index I plus this. What we really should do is we should say str points to str plus vertices of array index I plus that. That should work better. I think that would work better. But for 2D array, I'm not sure the best way to do that. So we can just do what we originally had. And if there's an error on there, then you'd have to change it back to something like that. So we'll just print it out like this for now. because the formatting for a 2D array print style, it's a little tricky. You have to print it out a special way, or else it's just going to be like one line across, or one line going down, and you won't know where your 2D array is, or like the structure of it. So here we'll print a new line. We'll print a new line here. We'll system.print out, system.out.print adj matrix. Excuse me, adj. Oops, no, in the string. Sorry. adj matrix. Like that. Then here we'll do the 2D loop, where int is I is equal to 0, I is less than so we're in I is equal to 0, I is less than. I think we could have did adj matrix here, but it works. It's the same number either way, I think. So let's say vertices.length. Then we'll say I++. We can change. We can be like test. Should be adj matrix.length. I think I might have made a mistake here, but it ended up working because they're the same size, perhaps. But then here we'll say for int j is equal to 0, j is less than adj matrix of index I, array index I, dot length, j++. So that's the trick for a 2D array. You have to say the original part of array index I, dot length. Then here you have to still format it a special way. So we'll system.out.print line adj matrix. Whoops, not as a string. Of array index I, then array index j. Oh god. Then we'll add a plus a space to space them out. I feel like we could have changed this to the str somehow. What's happening here? System.out.print line adjacent adj matrix. Oh, whoops, got a double thing there. Okay, so that's fine. Then here, don't forget to do this, because it's gonna not work if you. It's gonna print it out like in a straight line. Println. Yeah, sometimes I can type, other times I can't. System.out. .println. Then here we'll do just an empty space. Don't forget this. You need it to. We'll say you need this to print 2D style, or in a 2D style. Just leave it as short, and then we'll do return str. So can we change this? Probably. What can we do here? str points to str plus adj matrix. So what do we do here? Let's just say we said str points to str plus vertices of I plus a space, right? I believe that's what we said before. So in this way, for the 2D array, will that still work? It might, because here we're saying str points to str plus adj matrix I j plus space. Will that work? Because when we print it, yeah, it might work. We can test it after. You can try that. Usually I just print arrays with this, system.out, but that might work as well. str will get overridden. If you might need to do str2. So string str2 points to empty quotes and use str2 just in case, if there's stuff there. That might work. Anyways, this should work, so we'll come back. And I believe that's it. We can maybe do the iterators in the part 3 with the isConnected method, because that itself will take another few hours to do that. Probably, I'm thinking 1 hour, 2 hour, without shortest path. Yeah, we're looking upwards of 2 hours here for those. So I may make that in a part 3. Right now we'll just go with this. We don't need an iterator to print it. We can print it just with a toString, so that would work. What's up with that? Return ADJ matrix. Okay. That's about it here. So we could start instantiating some of this. There's probably some errors somewhere, but we will instantiate an object here. So we'll say graph of type string. We'll say graph points to new graph of type string. What do we take as our no parameters in our constructor? That should be fine. Do we have so it looks like it says we have 3 errors somewhere, but we'll get those in a sec hopefully. So we'll say well, let's just add 2 vertexes. So it's going to span capacity. If our array is full, then it'll set the vertices array of index 0. We'll store the value in there. We'll check, make sure that is false. That's it. Then after that, we'll do 2, and then we'll add an edge between 2 vertices. And this adds an edge between 2 indexes. We'll probably won't use that one. You can though. So we'll start with that. So we'll say graph.add vertex. Say like that, A. And here we'll say graph.add vertex B. And here we'll say, no, that's it. Graph, what's the method called? We'll add an edge between 2 vertices of the graph by vertex. Not, we could have said that here. So by vertex. This is by index. This one should be by index, I believe. So we'll just go here, say graph in main. We'll say in our main method we'll say graph dot add, what is it called? Add edge V for vertex. Okay, that's why I said V. So we'll add edge V between 2 vertexes. It takes a T, so we'll do A and B. So it takes our object between A So it might have been easier for these to take objects, perhaps. Like we could have said we could have created an actual vertex object. Here it's just of type T. Could have maybe created a vertex class and instantiated a vertex. Because here it's just going by equals A to equals B, I believe. Get index, let's see. So if it equals, see, that's the thing, it's just adding them between our strings. The thing is, we could have created like I will in the linked graph, but we can create an actual graph node. I mean, we could have even done that here perhaps, and change them to take a graph node. We could have instantiated a node of type graph. Could have called it like graph node. Then we could have said we want to add a vertex. We could pass in a graph node here. And we could say the graph node is holding strings. So that might work better. For that to fix it right now might take a while. I do have a pre-ready graph node class here, I believe. I made it for the next video. This one's for the linked graph. You can make it directed or undirected, doesn't matter, it's the same idea. So what I'm saying is we could instantiate these nodes. The thing is, this one holds an edge. No, it doesn't hold an edge. It has an edge to set. So it's a little different. This one, the edges are going to work a little different it's not going to be a true or false array, 2D array. The graph node itself is going to have the edge. It's going to have a pointer. So if you point it, so think of this edge as a pointer. I'll get into it in the next video, but if we say that we want this edge to point to the other one, then so think of this like a next. This is a next, and we're going to point that next to another node. And if we do point that next to another node, that's a point. That's an edge. That's a pointer. That means it's an ordered pointer. And if we point from the other node to this one to back to it, then that's an undirected edge going both ways. So that's what I end up doing. But in this case here, I'm thinking we could just create a simple graph object, literally just maybe with no edge. We could say that it's just holding the value. But I believe that would take too long. So you can set that up to do that. Maybe can I do an example here? So if we add a vertex, takes a vertex, so we would have to change this to take a graph array node or something. Then we would say that graph array nodes hold strings. So then vertex of num vertices. So we would store this. We would store the index. We would store the graph node itself. And the graph node itself would be holding the value. It can be done. I think it's better than this because right now all this is saying okay, well, we want to add an edge between the vertex, which is a string A. So it's not really giving us a proper memory location, if you know what I mean. I mean, I got an A plus on this. I got 100% on this assignment. But I just feel like we can make it better. But anyways, we'll just go through this way and just see. I'll show you what I mean if I'm confusing you at this time. So that's it. We're adding a vertex A, adding a vertex B, then we're adding an edge between them. So what it should look like is like this. A, and it's undirected edge to B. Then we could have like a how am I gonna do this? Probably down here. I have like maybe an edge to C. Whoops, we don't need those quotes. Then we can have probably something like this. So there's an edge between C, A, and B. Sorry, C to A to B only. But if we really want to, then we could connect 1 to, oops, nope, something like this. We can connect 1 to B. We could create an edge to B as well. So let's start off with this. So pretend, oh whoops, it thought that was an actual edge. Okay, so let's start with this first. So we have an A, we created a vertex A, we created a vertex B, and we added an edge between them. I'm going to show you what I meant is to actually create an object would work better. Because in this case it's just checking if the vertex A, it's just saying, okay, well the string A connect a point to the string B. It is a string object, it has a memory location, but it's not an object. It's a string object. It is an object, but it's not like a custom object. We want to create our own objects. So you could implement this class like that instead. Maybe we can try to change it. There's going to be some errors here somewhere. Okay, we'll do that one. Save and run it. That one, and one more. Hopefully just one more. Is connected. Okay, so we'll take that one out. We'll take this one out for now. Try to go for a part 3. We'll do that later on. Save and run it. It should work. Can we print it out? So at least it did compile. It's a good sign, so we don't have to spend hours fixing it. Okay, so our 2D array did not get printed properly. Actually, I think I know why. Alright, I think I used system.out.print line when I should have just used system.out.print. Let me see here. So this was toString. Yep. Yep, that's what I did. So there's a mistake here. Down, 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 down here. Okay. So system.out.print line, that's fine. System.out.print. So take the line out, take the ln out. And then system.out.print line, system.out.print line. Here we'll do a system.out.print here. Take that ln out here. Leave this one, just print the space. Save and run it. Should work this time. Okay, so there we go. So sorry, I had a diagram here somewhere. So let me just let me find that diagram to explain these true or false values a little better. Hash, no. Great, hopefully I didn't lose this. Oh, I know where I have it. I know where I have this file. Okay, so it's in my assignment folder. Should be some kind of note file. Alright, perfect. Okay, so this is best done in a note file. So how am I going to draw this? I'm going to need to draw a diagram somewhere, probably here. So here we'll have 0, 1, 2, 3, 4. We don't really need 4. You don't need 0, 1, 2, 3, 4. So we just had 5 elements. Index 0 to 4. Really don't need that. We could say default capacity is 4. Okay, we'll just leave it like this, it's fine. So we'll go back down here. Actually no, it's in main. So here we'll say we'll do some formatting. That's why it's easier in a no file, so you don't have to use the / stuff. So then here we'll have yep, that's gonna get a little confusing. So we're gonna move these up here. One back. Oh, that's fine. So here we'll have some lines like this. Nope, some lines like that. 0. That's too many maybe. Here we'll have one line like that. A line like this too. Yeah, 4 is way too much for this. We'll have, is that correct? And we need a line there. So I'm setting up a graph here, like an actual graph, like a grid, to mark off the values. Then we have 3. That's going to need 1, 2. Then here we'll have 1. Then here we'll have 4, and that should be it. Alright, so initially the whole thing should be set to false. I don't think this is enough space. False. False, false, false. The last ones are going to be false, for sure. Then we have 1, that's false. False, 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 false. This should fit, hopefully. False, 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 false. Hold down here, false, 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 false. False, 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 false. Alright, let's put some more there. Okay, so this is a grid here, right? So how can I explain? Let's move this up, by the way. Let's move this up too. Alright, so this is our graph. Rerun it here. So index 0 we have A, right? Index B we have index 0 we have A, index 1 we have B. In our adjacency matrix, so that means index, so where's our value stored? Where can I do it? I'll do it here. So I'll say index 0 we have index 1, sorry, index 0 we have A, right? Like that. And index 0 we have A, index 1 we have B. 0, 1, 2, 3, 4, like that, right? So these ones will be null or 0. No, I think they're null. So then we'll say, so what it's saying is, okay, well, index 0 is there's a value in there. Well, what value is that? Well, we have it at 0, 1, so that would be 0. So it goes row, let's go row and then column. So we have 0 and 1. We have so at the coordinates 0, 1, we have a true value, which means that there's an edge between the indexes 0 and 1, if that makes any sense. It's kind of tricky. Then if this was ordered, then we wouldn't need to have 1 on the way back. We could just say, well, there's a direct up here, there's a direct edge going from A to B, but not from B to A. But in this case, it's undirected, so we're going to say the symmetrical is true. So we're going to say that so 0, 1 is 0, 1 is that's true. So it's false, true, false, 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 true, false, false, false. That's for the first row. Second row is true, false, 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 false. The rest of them all should be false, which they are. So then we're going to say, well, index, so 0, 1. So it goes 0, so it goes row, which is across, which is down, then to the right. So it goes row, 0, 1. So it goes row by column. So it's like this, row, index, this first index is row in the array, and then second index is column. Or just call. So 0, 1, which is our vertices array. 0 to 1, so you can say pretend in this index there's like an edge here. 0 to 1. And index 0 to index 1, which is storing the value A, the value A and the value B. There's an edge there. So this if you haven't understood yet, this adjacency matrix, 2D matrix, it stores the edges, and this 1D array, it stores the values. But here we're saying, okay, well, there's an edge between A and B. This dash is just a pretend dash, just an imaginary dash, which it represents an edge. So we're saying, okay, well, there's an edge between A and B. At this current time, it's not ordered. It's undirected. It's directed. It's directed. So this graph is directed because there's only a pointer from A, an edge from A going to B, which is making it directed. But to make it undirected, we'd have to do the opposite. So 0 to 1, row and then column, 0 to 1, 0, 0, 0 to 1. So 0, 1, 0 we don't move for row, 1 we move across to the right. That's true. So that means there's an edge there. We could say that that's directed because there's only 1 there at this time. To change it from undirected to directed, we just have to change that one thing. We don't have to do the symmetrical, which is what we're gonna do now. We're gonna say that, well, if it's going from 0 to 1 in an undirected graph, that means it would go from 1 to 0. So we'll go 0, 1. So 1 and then 0. So this one will get set to true. That means it's undirected because it's going both ways now. So hopefully you understand. We'll probably do one more at least. So here we'll say, well, after that we're going to add a vertex. So we'll go graph.add vertex. We still have to actually do the debugging. So we're adding a vertex C now. We'll just say there's C. We'll just do one path like this. And well, there's a connection between A and C, which is undirected. oops, sorry, add edge V, add edge V, like that. And we'll recompile that. That'll give us a C there and some more true values. So now we have C in there. Put a pretend edge in there. Well, where's edge now? Where's the C edge? It's in 0, 1, 2. Where do we say that there's a connection between A and C? Well, A's 0, B's 1, C's 2. So 0 to 2 and 2 to 0 will have an edge. Where is it? So 0. We said 0 and 2. 0 to 2, because A is 1. You can put the numbers above if you're confused. So we'll say, okay, well, there's a 1 here. Sorry, 0 index, 1 index, 2 index, 3 and 4. So we'll say, okay, well, between, now we have an edge between 0 and 2. And since it's undirected, it'll be 2 to 0. If it was directed, we could just have it one way. So we'll say, okay, well, 0 to 2, 0, row, then 0, 1, 2. We should have a true here. 0 to 2. And the opposite, so 0, row, so 0, 1, 2 column, then 2 row, 0, sorry, yeah, 2 row, 0, 1, 2, and 0 column. We'll have a true there as well, right there, true. So that'll get changed. Hopefully you're understanding. And really that's it. So that should be correct. False, true, true, false, false. True, false, false, false. True, false, 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 false. True, false. Same thing, true, false, 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 false. True, false, 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 false. And the last one is false, 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 false. So 5 of them. Oh, whoops, one more. False, 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 false. The last one also will have false. All the way across. And that's it. So we'll just probably start debugging it. Yeah, so then the next part would take another few hours as well. So that's what I was saying. It's really just adding the string. It's not really adding. We should have a graph object. Not a node, at least, not a graph object, sorry, a node object, maybe some kind of, no, a vertex object, sorry. We should have a vertex object, or some kind of node or something, just to store, just maybe a better implementation. I'll try to explain that in a sec. So we'll jump into our graph, it just sets up the num vertices. To 0, instantiates 2 arrays, and that's it. So you can see here we have a graph object which has 2 arrays in it. Single dimension array, you can see the memory location where it's stored. ADJ matrix, there's our whole matrix. You can see it nicely. Vertices saying it's all null. And all these values get set to false initially. So we'll jump into add vertex A. If it's full, so it's not full, we're not going to expand capacity. So vertices array of index 0 points to the string A. It's just going to make sure it's false. Then plus plus. So we can check our vertex for a vertices array. ADJ matrix, it's the same. Vertices here. See, it has index 0 storing A. And we'll do the same thing again. Set some to false just in case. Then we have vertices index 1 storing B. Add edge between there. So we'll call add edge get index. Where's get index? We already skipped through that. So it looks like it just kind of gets the index without, I'll just stop that and restart it. So we'll move that breakpoint down here and restart. So yeah, it looks like the passes in get index, it doesn't really go through that apparently. So that's okay. So we're just saying we're gonna add edge with these vertexes A and B. Oops, just gonna start that again. I think it's skipping. It's actually skipping that method. Add edge. It's not going to get index. It's skipping that for some reason. Where is get index? Down here. Yeah, so all it's doing is saying, well, if the index equals to the object, set an edge between them. What we really could do is take a node and compare. So this is comparing by strings. By string, I think it is memory location. But what we could do is, instead of comparing by strings, we could compare directly by memory location. So if I just confuse anyone, I just said memory location twice. Well, strings are objects, so they have their own string memory location. But I'm not talking about a string memory location. I'm talking about our own memory locations that we can create ourselves, like we did before in the link stuff. Like if we go here's a memory location. Our adjacency matrix is stored at 973. Well, what we could do here is we could store a vertex. We could create a class called vertex, right? Then we could say, okay, well, vertex stores objects. Okay, even make a class now. So just as an example, I don't know if we'll do the whole thing, but we'll say, okay, well, this is a vertex of type T. It's going to store objects of type T. Then we'll say, well, the vertex stores a T val, T element, whatever. Then we'll say that that's it really. And we'll say, we'll call our vertex constructor. We'll say that it takes a T val. We'll say this dot val points to val. We'll say public T get val. We'll say return val. And here we'll say public T set val. Takes a T val. We'll say this dot val points to val. Actually, no, this should be void. Public void set val. So this dot val points to val. That's it. That's all we need. I think something like that. It won't need to be as complex as the other one because we already have a place to store edges. So in this case, we could maybe we can create a method to instantiate the vertexes, or we could instantiate some here. We could be like vertex A points a new vertex, takes a value. Then we could say vertex B points a new vertex, whoops, and our vertexes store, they store a value, which is a string. So here we said vertex of type string, whoops, forgot to do that. Vertex of type string, vertex A points to new vertex of type string, done. Should work. Here it's going to say raw type, I believe. We'll say vertex, and we'll say string, vertex B points to new vertex of type string. So now we have our own vertex object. Now it's not just stored as a string anymore. We can't even get to that method, by the way, which is dumb. It's not showing it, but what it does do is it's a glitch in IntelliJ. That's another glitch. So you may experience glitches with IntelliJ. I'm just gonna have a sip of my water, one sec. Oh, and it's spilling everywhere, wonderful. Alright, so let's try to use these methods here, so let's overload them then. I guess we're getting into it for real now, so we'll say that, I guess that's over here, right? So let's take this whole thing, copy it, software reuse, technically. We'll say, okay, we got that. We'll take it to take a vertex of type T vertex. What's happening here? Okay, so then we're gonna have to change our array itself too. Okay, let's do that then. I should have maybe done everything as an example first before we got into this. Maybe we should do that first. We just added some removing. It's nothing. It's really the same thing. Whereas remove. Yeah, so here it just compares if it equals a vertex. If their string equals, if our value stored in our vertex string equals the vertex that we've. Okay, let's do a few examples here before we start changing this whole thing. So what have I changed so far? I copied this, I overloaded this. So let's comment it out. Out of here, haven't changed this yet. Okay, so here should still work, hopefully, because these are just instantiated. Hopefully it does work. Okay, so it does work. I just want to show you what these objects look like. Have a look. We'll have a vertex B, vertex A, has its own memory location compared to graph, which is holding vertices. See, A has a value with its own string object. That's getting, that's not what we really want. We want a vertex like this. Here's a vertex object. It's stored in memory location 953. Its value is A. Something easy like that, and something that we created. An actual memory is going to compare we want it to compare memory locations versus storing values in a string, because if you were to create some kind of code where you wanted to change your password and someone was like, well, I know the password, but I'm not actually have access to the account or something, they could just give you the password, and since the string matches, it would change. But what we actually want to do is take where the original owner's password, where it's stored in the memory. That's what we want to change, not trick it to store just because we have the same values, if you know what I mean. So hopefully that makes sense. Let's just remove a few. Let's comment C out for now. And we have those, we have this. C we can take out for now. Okay, let's just leave that stuff for now. So we'll say, here we'll say, actually we don't really need these at the moment. Let's take C out. And we'll take C out there too. Oh, and we messed up this thing. Okay, let's just leave it like that, because we're going to change that in a sec. We're going to remove them in a sec. Okay, so that makes sense. So that's fine. So here we'll say, we'll look for a remove method that we want. Remove vertex, remove the single vertex with a given value from this graph first occurrence. So that's what I mean, first occurrence. So then if we have a bunch of letters in here, it's just going to remove the first one. So the first A. This one's going to remove vertex based on index. That one would still be valid. Would it? Vertices of array index I equals val. What's val? T val points to vertices of array index. Okay, so some of this would still have to be changed if we were implementing it differently. This removes all edges connected to it. This removes an edge between two vertices. We're removing a vertex to start. And that this one removes an edge between two vertices based on index. Okay, so it's a little confusing, but we'll start with this. Well, first we're going to remove the edge actually. So we'll remove the edge between A and B first. That way we can do that and then remove like B after. So here let's just go graph, remove edge between, not all edges connected to, we don't want that. We want remove an edge between two vertices. We could do it by index too. We could do it by index because that one's going to our get function that we don't actually get to see. So we'll do remove edge int index, which takes an int. Okay, so we'll, was that V? Yeah, remove edge V. Oh no, we want remove edge. Just remove edge. So we'll say graph.remove edge between 0 and 1. And we'll step into that. Stop debugging there, start that one. Oh, this is getting to be a super long video. I think we're at 3 hours now. Alright, so we'll see, so we have graph.remove edge. Graph.remove edge. So we'll step in. So right now we have graph num vertices, no. Vertices we have A and B. We want to remove the edge at the exact points. So if index is valid, we'll check. Is the index less than 0? We could have checked if it was greater than as well, but that's fine. If index is less than, if index is less than num vertices, that's true. Num vertices equals 2. So we just have index 0 and 1 full, so less than 2 would be correct, so that's correct. Because if we have 2, then it would be a null pointer. That's correct. It's going to check both of them apparently. So it's just going to set them. It's just going to set the matrix. It just checks if the index is valid, so this one's fine. It checks if it was an index, but if it was a valid index where a value is stored, which it was fine. So then here we'll say that adjacency matrix of index 1, which is 0, and then adjacency matrix of 0, 1 will get set to false. So here we'll say 0, so row, column will get set to false. So we're taking that edge out now. Where we were here, we'll step into that. So you can see them here too. This adjacency matrix. So we have 0, 1 set to false, then we have a true down there, so that one's going to be changed. So then adjacency matrix of index 2, which is 1, index 2, which is 1, and then comma 0. So adjacency matrix 1, comma 0. Adjacency matrix 1, so row is 1. Sorry, row is 1, so down here. Then column is, no, row is 1, and column is 0, yeah, so row is the first value, column is the second one, so row is 1, and then column is 0, so we're going to set that one to false. And then here you'll see that value change. That's, is that the first one? Yeah, that first true will get set to false. Right there, false. See, got changed. Edge count minus minus, mod count plus plus. So we have our new graph right there. All the edges were removed, but the vertices are still in the array itself, in the vertices array. Because if we see our vertices array here, we still see A and B. We have a vertex A and B, but they're not. There's no connection between them. There's no edge. So if we stop that, we can delete those. So what's our method to remove the vertex? Did I skip them right there? Nope, edge. How many edge methods we got? Probably 3 of them, and then 2 vertex ones, I think. So remove vertex by index, remove vertex by the object itself. So we want this one. Public void remove vertex v. Okay. Takes a vertex. It takes a object vertex, so we'll say, or a string object at least. We'll say graph.remove vertex. We'll say you want the vertex A to be removed. So right now it's just checking by the object. We want to change that to actually check by the memory location. I know I don't want. Excuse me. Falling asleep. We just want the index, not the the actual string stored. So we want to compare those by objects in a moment here. So we'll step in here, setting boolean found to false, where int I is equal to 0, I is less than num vertices. Num vertices is 2, I plus plus, so I is equal to 0 this time. If vertices of array index I, see it equals, so it's comparing by string because the string overrides the equals method in the object class. So if vertices of array index I, which is 0, dot equals vertex, which is A, which it does, found is equal to true, vertices of I set to null, right? Done. That's what we don't like. That works, right? We're storing a string object and checking, but okay, so now we got through that, we want to change that. So what we want to do is change those methods. So first this one. done with that, I'm going to start changing these. So we're going to change the vertices array to an array of type vertex. I think that will work. Hopefully it does. And does that work now? Nope. Then this one will comment out. Instead of doing that, maybe could we just create another one? So protected T, no protected vertex of type T array vertices. Already has that name, right? We just call it vertex array. Okay, so here we'll say which one's the overloaded one. Vertex array. Will that work? So we're adding a vertex. Vertex array of array index number vertices points to vertex. We can try it. It might take a while for me to actually do this, but take these out. Okay, so let's say graph dot add vertex to vertex A. Let's test it. Step in if number vertices +1, so that should be fine. Null pointer exception. Vertex array of array index 0. Why is that? Vertex array. So we're creating a vertex object right here. Type string, yeah. So we're trying to add oh, we didn't instantiate our array. I think. Yeah. Because we have this dot vertices. So we'll say vertex array points to, whoops, just 2. Have to cast it to T array. New object. Default capacity. Hopefully that works. Nope. Require type vertex of type T. Okay, vertex. Cast a vertex of type T, yep. That's what we need. So I'm just going to use the cast. So let me copy that there just to show you what it was. Oops. Alright, so I copied it. What the heck is happening here? So what we're going to do is we're going to cast this to vertex of type T array. I'm going to hit Alt Shift and Enter. It's going to do that automatically. Or we could just try doing it here. Vertex of type T array. Okay, that works too. That is asking for... Wonder why that's... Hopefully it doesn't. We might get some exceptions here and there for the types. Hopefully it does work. If not, it could take me a few hours to figure it out. What is this? Whoops. We need to store an array. We need to store an array of type vertex of type T, which is storing objects of type T. What is our message saying here? Great. Still not working with this. Oh yeah, maybe because it's the constructor itself. Class cast exception, okay. Great. We're having a problem with types here. So is there a quick way to fix this, or it could take me a few hours to figure this out maybe? Define cause, Alt Shift Enter. Able to find cause. So we need an array of type to store objects of type public. Let's try that. Oh, damn it. I thought it was going to work. No, it's going to work, maybe. I don't think. Because now we're using another class, so maybe changing these would help. Is there an easier way to do this? That's what I'm trying to figure out. Again, this part itself could take me a while to figure it out. So I may just leave you guys on that note and try to figure it out and come back. But is there a quick fix here? Not sure if that works. We need a vertex array to store vertex objects. Maybe this instantiation itself is wrong. Could we do T array? T, no. Casted vertex to type T array? No, because we need a vertex of type T array. Can we just instantiate it like that? Points a new vertex of type T array. Default capacity. generic array. Great. Generic array creation. That's fantastic. T-array, that's not going to work, is it? Cast it to an object. Nope. Oh man. T-array. No, that's not going to work, is it? To vertex array. No. That's too bad. That sometimes types can mess you up like this. Oh, is anything wrong with that? No, damn it. For non-null values. Why is that? Is it the constructor itself, or what? It doesn't like that for some reason. Vertex of type T array points to new object of default capacity. We don't need to store them in an array, though. As well, we could just store them. That's what I'm going to do in the link class, in the link graph class. It would already worked. I already compiled it. But it just doesn't like this object array. Could I type string here? Will that work? It says they want vertex of type T. Unless I change this to string. Maybe that would work. Vertex of type string. Instead of vertex to vertex. Let's try that. This dot vertex array points a new vertex of type string array of default capacity. Generic? How is that generic? I'm saying of type string. Great. Can I instantiate this array? Nope. Because, damn it, why doesn't it work? New vertex. New vertex. Vertex of type string array. Vertex array. Then we say vertex array. Points a new vertex of type string. No, that is crap. What's wrong with that? It just doesn't like it. Vertex of type string object, because we're instantiating the array. Okay, here we could say vertex of type string. No? Maybe? That won't work? No, damn it still doesn't work up here. How is that generic though? I'm saying that it's a type of vertex of type string. That is super dumb. Alright guys, so I'm probably gonna stop it here. I'll either make a part 3 if I figure this out. If not, we'll just do the type. We'll do the actual object type in the link graph. So if this, just in case I stop this video, actually, will I stop this video here? I might. So if I don't do a part 3, I hope this video did help you understand graphs for an array implementation. If this video helped you in any way, you can subscribe to my channel if you'd like to see more free coding videos or any free trading or investing educational content. If not, that's okay, and I'll see you guys next time. Take care.